Hello and welcome to another episode of the Clojure Builds screencast. This is episode number 12 and the macro we are going to see in this episode is memfn. But as usual, before we start, a quick announcement about the book I'm writing for Manning called the Clojure Standard Library and Annotated Guide. This screencast is roughly based on the content of the book. So if you enjoy the screencast, you might very well enjoy the book, which contains many more details, is extended much more compared to the content of what I can show in the screencast. I have a 42% discount code on the slide if you want to use it at checkout to buy the book, which can be found at the website that is also printed on the slide. And finally, my Twitter handle at reborg if you have any question or if you want to get in touch. Memfn, so what does it mean? The name. So the best mnemonic I found it on an old thread on the Clojure mailing list, and I think is, as far as I'm concerned, is one of the best mnemonics I found is member. So mem stands for member, and fun stand for function. And this has to do with the goal of memfn, which is to invoke instance methods on Java objects. Let's quickly check the Clojure doc, which essentially explains that memfn is generating a function then expects a target object, and when you invoke memfn, you pass a name of an instance method that should be invoked on that target object once you invoke the generated function. And it also allows you to type hint somehow the target object in order to avoid reflective calls. So there's quite a lot of to explain, I think, here, and better if we start with some example on how to use memfn. It will be much clearer after we saw a few examples. So memfn can be invoked with a single argument like this. In this case, toLowerCase is an instance method of the string class in Java. So since memfn generates a function, I can attach it to a def in the current namespace, so I can then use it like this. And as expected is transforming it to lowercase something that is in uppercase, a string that is in uppercase. But the main reason, or one of the main use case for memfn is perhaps the fact that it can transform what is not a higher order function or a fully qualified Clojure function into something that resembles or works like a higher order function in Clojure. So what if I wanted to apply the toLowerCase function to multiple strings? So I might be tempted to do like this here, map toLowerCase to this list of strings. But if I do that, it's going to throw exception, because at the point of invoking map with that function, toLowerCase is just a generic symbol. So Clojure doesn't know that toLowerCase refer to an instance method on some class. And memfn can be used in this case, just expanding a little bit on the number of forms you need to use, but it's not too bad. It can be used in this case to wrap toLowerCase and to obtain exactly the desired effect of lower casing multiple strings in a collection using a map function. We saw up to now what happens when we have an instance method that doesn't take any parameters itself, but something like index of, again on a string instance, is requiring the target object and also a parameter which is the substring you want to search the index for. So index of a specific letter like A in ABBA will find should find 0 as a result, which is the first occurrence of A in the string. Memfn can be used for this, and when you use it with multiple arguments, like in this case, index of and ch in this case, is generating a function of 2 arguments instead of a function of 1. So I can use it with map again, and in order to have multiple arguments, in this case 2 arguments for the mapping function, I'm using 2 collections. And the first collection contains the target objects, 3 strings, and the second collection contains the substring I want to search for. And if we run it, we can see that is working as expected. Just to be clear, ch is arbitrary, so the important thing is that you indicate to memfn that there are multiple parameters and that needs to be passed to the instance method invocation, but it doesn't matter how you call this. And just for fun, I picked up here an emoji UTF-8 to show you that it works exactly the same way, and it doesn't need to be a specific symbol. It can be any, but it needs to be there. For a more involved example, I want to show you something that has to do with calculating duration of instance. So there is a class, or there are 2 classes in Java that we're going to use now in Java time, an instant class and a duration time that can be used to calculate duration of, can be used to calculate the distance between 2 instants in time. So I have here a generator helper, which is generating instance for me, and to make it a little bit more realistic, I'm waiting 100 milliseconds between each instance. So if I now take, for example, 10, I'm sure if evaluated, if I take, for example, 10 instances, you can see that I'm getting back a collection, a lazy sequence in this case, of 10 instances that are roughly 100 milliseconds apart. As I said, it's a lazy sequence, it's also an infinite sequence, so you always want to take some specific amount of elements from the lazy sequence. What I want to do though is passing this instance, some amount of this instance, to a durations function that is going to give me in output the distance between each of the instants in the input parameter to some starting point in time. So I have the option of passing my own t0 here, or the function will pick up instant now if I don't pass anything. So the instants are going through this threaded operator down to first a map, which is calculating the distance between the instance, the first instant for instance, and the start time. And this duration is then passed to memfn, so it can be transformed into milliseconds. If not, it will be like an instant object. And finally, I'm just turning those milliseconds into seconds so they are easier to read. Interestingly, you can see that in order to map an instance method, I'm using memfn, as explained before. If instead I have a static method like duration/between, like in this case, memfn wouldn't be useful in this case. You need to explicitly use a function literal or like a lambda in this case, and be explicit about using duration between. Let's try to evaluate this and use it. So you can see that now I'm picking 2 instances from my like lazy infinite sequence and passing them down to the duration function, which is calculating the distance of each of those instances with some initial time t0, and you can see that it's returning a couple of numbers there. I need to do this, like to explicitly realize the lazy sequence at this point, because if I don't do this, everything will be realized at once when the sequence is printed on the REPL screen. So at that point, the instance now will be almost irrelevant. Everything will be evaluated at the same time, so you would see strange numbers, either negatives or zeros. If I instead realize the sequence right away, like in the let block, at the time the local binding is created, then the duration is actually doing what I'm expecting, calculating some distance between time, which is something you can actually print and see. As a secondary example, I'm also showing you how can I calculate the distance between this instance and a specific time that I pick up. In this case, it's not instant now, but it's some time t1, which I'm selecting here as instant now, but it could be any other instant coming from like a third-party service or anything like that. And I'm doing the same thing after that. And in order to make it clear that the initial instance is coming from the let block, I'm waiting 200 milliseconds. So what I expect here is that the duration should be roughly, of the first instance, should be roughly 200 milliseconds, which is what is happening there, plus or less the execution time. Good. So we saw an application of memfn for like durations. Another thing that I find I'm doing quite often is when I'm loading a list of files from the file system using filesec. That is also returning folders mixed with files, and I'm mapping the function isFile, or I'm using filter isFile using memfn to remove all the folders or keep all the folders depending on what you want to do. So that's another use case I remember. Some implementation details to finish. So we can see how memfn works, and it's not very surprising with macro expand, and it's generating a lambda function of one argument in this case, and you can see that the parameter of the generated function is then used as the target object for interoperation. Let me highlight what I'm saying. What I'm talking about is this line here with uppercase. I can evaluate memfn with 2 arguments just to see what happens, and you can see in this case that instead the function generated has 2 arguments, and one is again the target object, which is used in the same location, but ch in this case is used at the end as the parameter for index of instead. When we look at the sources, there is an interesting detail we can notice here, which is that it is memfn macro is taking the metadata from the name, which is the name of the instance method you want to be called on a target object, and is transferring those metadata onto the target object with meta of meta name. So it means that when the function is generated, this first argument here, which is the target object, has metadata that are coming from the memfn invocation, and we can use those to prevent reflective call. And so let's see why that happens and when that happens. And in order to see that, we turn on warn on reflection as true, so we can see if there is any reflective call. And indeed, if I try again the lowercase example that we saw at the beginning, it's working as expected. It's also printing a reflection warning, and the method, the call to method to lowercase cannot be resolved. And the reason is that at compile time, macro expansion time, Clojure doesn't know the generated function on what will be called at runtime. And it's exactly the same that happens if you try to do Java interop and you call methods on Java objects. If you don't type hint them inside a function, for example, you'll get a reflective warning. And what you usually do is you type hint the target object. But as you can see here in the memfn invocation that we're doing here, there's no target object. The target object is the string A here, but the string A here is in a collection, so I'm not going to type hint that. What memfn offers for this, in order to fix this, is that you can pass those metadata down by decorating the first argument, the two lowercase, like I'm doing in this other example. So I can decorate that with a string type hint, and that will be propagated down to the generated function and into the target object, which will accept uppercase A and uppercase B later on. When I do that, the reflection warning goes away, and with this very simple benchmark using do times and time, I can see already like a speed up. And this is just it's a very unprecise way to do benchmarking, but when reflective calls are involved, is usually enough to see the difference. But you shouldn't do that. You should benchmark with criterion or libraries like that. I think this was all I wanted to say. So as usual, thank you for listening and watching the screencast. The show notes will be soon available on the Clojure Pills GitHub project at that link that you can see on the slide. And I hope you enjoyed the screencast, and until next time, take care.